All right. Guys, I really want to thank you for coming to my session. So this is the Web Can Do That in case you've misplaced what session you should be in. Apparently none of you want to get free Android hardware downstairs, so I do really appreciate your time for the next hour. This is going to be adventures into HTML5. And just so you know who you're talking to up here, my name is Eric Bidelman, and I work on the Google Chrome team. I write for HTML5 Rocks. I'm an advocate for Chrome team. I teach developers HTML5, help them use it by writing tutorials. Of course, if you want to contact me, there's Google+, there's the Twitter, and there's also a blog that I don't write to very often, but it does have some interesting things, I think, on it. So that's who's up on stage. I get this a lot. People are really skeptical about HTML5 still, and so they don't know what's possible. And so part of my job is to come up here and teach you guys, and YouTube, the folks at home, what is possible in the web. So today's talk is that the agenda is there's going to be no agenda whatsoever. So I'm going to sort of highlight really cool, interesting use cases that HTML5 can now solve that you probably didn't know were possible on the web today. Things that you probably need to build a real-life real-world application on the web. So a little bit of convention about this slide deck. This is a living, breathing slide deck. I'm doing something a little bit different with this. You'll see in the top right corner there's a legend. There's a radar, and that signifies this stuff is on the radar. Keep it on your radar. It's still pretty new. It's changing quickly. I can actually make CORS requests, cross-origin resource requests, cross-domain XHRs, to the WebKit issue tracker, which is really nice. So as soon as a bug is fixed, I know when it's fixed, and I can mark that and denote it with this little bug guy as it gets crossed off. So you kind of know when you go back to this slide deck later at html5can.com. Not up right now. I'll post it after the slides. But there's spec links, and you know the stuff is up to date. Okay, so without further ado, let's jump into the number one main awesome, sweet thing that the web can do. And the first is that we have CSS for web apps. And you're probably like, whoa. Oh yeah, Mythbuster style. So you're probably like, whoa, Eric, like we've had CSS for a long time. What's up with that? Well, we've had a lot of great stuff in CSS. We've had floats and absolute positioning and tables and all this stuff kind of working together. But the real problem with that was that it was all designed in time of websites, not web apps. So if you really want to do complex web layout, it's very, very hard until now. So I'm calling 2012 sort of the rise of CSS for web apps. And that's because the working groups have proposed just a slew of new stuff that we can play with eventually as web developers. Regions for things like flowing in a magazine-type layout and design. Flexbox layout, which I'm going to talk about, it's one of my particular favorites. Being able to easily position things on the page in a flexible manner. Grid layouts and hierarchies. In ASCII and in CSS, you can define where things show up on the page. I mean, it makes sense, right? If you're building something on top of CSS, you need engines and different mechanisms to do that for web apps. And then there's the bells and whistles. There's the hierarchies, there's the filters and effects, and other really cool stuff coming along the pipeline. CSS variables, if you guys attended the web component session earlier, that stuff is finally coming to CSS. I can finally use variables in CSS. It's not that exciting, but it's super exciting as a web developer. You don't have to use a processor anymore. So why am I picking on Flexbox out of all this new stuff? Flexbox is really great for web layout and design, and it's really going to solve and is solving the sort of common use cases of a web app. So that holy grail layout, right, that header, that footer, that sort of three-column tiered system, very hard to do, notoriously hard to do with CSS today, very easy with Flexbox. And so the way Flexbox works is that there's a new display property. So I can tell a container to be a Flexbox container. And I'm doing also something in this slide deck. Nobody's going to catch me on vendor prefixes. I'm using sort of a compile type syntax, a mix-in syntax, to denote that anytime you see a plus for CSS, that means vendor prefixes are involved. So I can tell, for instance, this red container to be a Flexbox container with display vendor prefix flex. And we can do things like center content horizontally and vertically super easy. With 3 lines of CSS, we can do this now. We don't have to set negative margins or use JavaScript. So along my main axis here, this is a little bit of Flexbox terminology, and my cross-origin axis, I can justify content to the center. I can flex it to the start. I can say everything be justified to the right. And I can also align those items in that cross-axis. So I can align items to the center. I can align them to the bottom. I can do things like stretch to take up the available content of your parent container. Very, very handy with layout. And I can do also things like distribute yourself evenly in the container, take up the available space, and put an even distribution of white space around yourself. Another cool thing about Flexbox is that it completely takes away the sort of mapping of your source to how things are rendered on the page. So typically what happens is that you define your A, your B, and your C div, right? These are just 3 divs inside of this Flex container. And that's how I've laid it out in my markup. So I have A, B, and C in my markup. But maybe I don't want to render A, B, and C in that order. And I can do that through different properties of Flexbox. I have this flex direction property. So again, vendor prefixed. So right now we're flexing in a row, but I can choose to change the order of that row. So I can reverse the order of the row using row reverse. I can tell these items to be in a column. So A, B, and C are not in a row now, but they can be rendered in a column. And then using the order property, I can sort of change the order depending on what value I set here. So by default, these are all the same order, just as they're laid out in my markup. But I can tell the second div, the B div in this case, to come before A. So this is independent of how I've laid my markup out. I'm just rendering this differently to the page using the orientation and direction properties of Flexbox. I can also tell it to come after everything as well. But another really cool thing that Flexbox solves is sort of this type of use case where you have the same height columns. So in order to do same height columns, right, this is a great example of just floating 3 divs across the page. But if I want to do something like make these even, right, and have a really awesome UI, I can do that with a little bit of JavaScript, right? I can set these and get the computed style of the content and know exactly how tall they should be. But what happens if my UI is being rendered through JSON, or I'm pulling in an RSS feed or something, and my content is dynamic, right? So as soon as that happens, I pull in a little bit more content. My columns are now out of sync. I have to recalculate. I have to touch JavaScript. I have to set properties in CSS. It just feels super, super icky. And so the way Flexbox solves that is through its bread and butter, flexibility. And so it's really nice. I can tell things to take up the available amount of the parent container. In this case, all of these items, A, B, and C, are equally distributed in the Flexbox container. But I don't have to do that. I can tell the second difference to be 2 times greater, right? Grow it to be 2 times as big as your siblings, or 3 times as big, or 4 times as big. I can also tell it just to shrink. So A and C will be equal size with a flex property of 1, and then B is going to be a negative flex property. So that's really handy when it comes to that holy grail layout. So I want to show you an example of this. This is a live page. Think of this as that holy grail layout, that header, that footer, that 3 column in the center. And the first thing you'll notice is that this whole thing, maybe not in this resolution, but the whole thing is centered vertically and horizontally on my page with 3 lines of CSS, right? That alignment and justification there. Next thing I have on this page is a really sweet navigation bar. And you'll notice that that last button up there has more content than the rest of my buttons. But that's OK. We can tell these Flexbox items to grow and shrink. So all my buttons are exactly the same size. I didn't set anything in CSS, particularly the widths of those buttons. It's just flexing to take up the available space of that complete web app. But if I add more, all these buttons are going to continue to flex and be of equal weight and size and distributed evenly. So it's great for navigation. It's great for UI. We can also use some CSS transitions on the flex property. So I can do really cool UI effects like little zippies here. So these are just Flexbox items within a Flexbox container with the column orientation. And with a little CSS hover, I can tell them to grow with the flex property to be 2 times or 3 times greater than the rest. I have my centered content in the center of that article content. I can use transforms to do things with vertical alignment there on the side, my navigation on my side. If I wanted to, I can combine this with media queries. And you remember I could independently order my source and how things are presented using that order property. So if I combine this with media queries, maybe in my mobile UI, I have something that's different. So if I scale this down to sort of a mobile UI, notice in the case of my desktop, right, the article is in the center. That's my main content. That's what users should be seeing. But when I scale down to mobile, maybe the article should come before that navigation element, that zippy on the side. So I can do that with that ordering and orientation property. Very handy when combined with media queries. So that's CSS Flexbox. And that's the new one. There is an older Flexbox if you've been following this stuff closely. And that's actually available in a number of browsers right now. So WebKit Nightly and Chrome. IE10 will have the new Flexbox as well. So you can expect to use this relatively soon. All right, number 2 amazing thing is dynamic CSS. By dynamic CSS, I actually mean, yep, that one's confirmed too. I actually mean the calc function. If you attended the session earlier today on web components, they have CSS variables coming. But we actually have the ability to do this similar things now with the calc function. It's been around in Firefox for a long time, just came to WebKit very recently. What I have here is a live example of something that's in the Flexbox specification. So I basically have a bunch of divs. I have a div within a div within a div within a div. And I've put a border radius of 50% on this div, so that's what's creating the circles. I've specified the parent circle container to be 300 wide and 300 tall. And what's really nice about this is I can use the CSS calc function, so again, vendor prefixed, to calculate each of these inner divs to be 100% minus 4em. So each of these children divs is 4em smaller than its parent container. So that's what's producing sort of this target effect. What's really neat about this is you combine it with what we just talked about, which is Flexbox. And so that's what's doing the alignment of the center and justifying the content of the center. So that vertical center, that horizontal center with 3 lines of CSS now, combine it with the calc function, and you can do something like this, which you haven't been able to do before without a little bit of JavaScript. Really awesome that this stuff now can work together very easily with a lot of new CSS stuff. And support is actually really good for this, as you can see by this slide. So that's dynamic CSS. Number 3 amazing, awesome thing that the web can do is data binding. And you're probably like, what? Web can't do data binding. Oh, but it can. But this is actually old hat for JavaScript frameworks, right? If you've used a framework like AngularJS, for example, one of my favorites at the moment, data binding looks like this. So this is how they define a template in Angular. It's just HTML, which is really, really nice. I don't have to learn sort of a new API or markup. But if I want to do one-way data binding, I can have an input. I can change the input, and as I change that, my template is being re-rendered. I'm just re-rendering the value of the input as it changes. And that's done through sort of Angular's magic. My model, in this case, is this val. That's what I'm calling my model. And as I change the input, val is being re-rendered to the template. So that's one-way data binding using a JavaScript framework. But we can actually do a neat little trick that I kind of discovered, which is I'm calling it poor man's data binding. And it's using data attributes, HTML data attributes. So we don't need a framework to do one-way data binding. And the way this works is that you have a data attribute. That's your data model. That's where you're going to be storing your values. And then a lot of people don't know, but there's this really awesome, amazing attribute method that you can use to pull out values from the DOM and use those values in CSS. So that's how we're going to get the data from the data model. And then our view in this case, what we're rendering this data to is generated content. So before and after pseudo elements, and generating that model to those elements. And then so we don't have a JavaScript framework to work for us in this case, so we have to actually hook up a little bit of event listeners to do this and watch for the changes. So what you get back with poor man's data binding, is exactly the same thing. So I can have an input, and as I change that input, I can re-render that to my template, my pseudo elements on the fly. So it's a small amount of code to do this. I set up an change event on my input. And then as that input changes, the user changes it. I'm setting a data attribute using the data set object. So data-value is my thing that I'm changing to the new value. And the really cool part of this is that I'm using before and after pseudo selectors for this. So I'm using that attribute method to rip out that data element, that data attribute from the DOM, dividing it by the max attribute, in this case 100. So you get the exact same thing as the AngularJS case. I don't need a framework to do this type of one-way data binding. Now, you could do the exact same thing with an extra span or DOM node and just render the inner text of that. That's cool. This is a little cooler in my opinion. And it illustrates that we can do this now in HTML5. But we can also use something better, which is the data list element, something new to WebKit, and Opera's had this for a slew of time. But this is sort of a semantic way to do one-way data binding. So in this case, your data model is actually defined in markup. You have data list element. You can reference it by an ID, so I'll list the browsers out. And each option is sort of the values of this data list. And then what we bind to in this case is an input element. So we reference it by the list attribute via an ID. And so we're binding this data list values, these values to this input element. And so it's a great way to do things like autocomplete. So I have an example down here. I have the list of browsers, and when I click on this, right, I get the values that are from that data list. So we bound that data to this input. Now, if I do things like or if I start typing, right? Just as you expect, I have autocomplete behavior. That's super handy. That's the HTML5 way to do one-way data binding. And you actually saw in that blue column example, you saw me use this data attribute trick as well to render out the heights of those columns as they were changing when I clicked on them. And both of these methods for data binding are actually supported in all the modern browsers, which is really, really sweet. If you're doing something simple, like I just showed you, you can use one-way data binding just with HTML, just on the web. How many people think HTML can access a file system? It's hard to see up here. We have some believers. We have a lot of naysayers. It's cool. This one's totally confirmed. It's confirmed because I got really excited about this one. I got so excited that I wrote a book. Shameless plug, I know. But what we have now in HTML5 is a file system API. This is something that you can do very easily in a native app, right? You can read and write folders and persist data. That's very common. We should be able to do this on the web as well, and we can do that with the file system API. So there's a new property on the window method. It's called request file system, and this is vendor prefix as alluded to by this underline here. You can open the file system and read and write files and folders. That's really huge. The security behind this is exactly like the other offline storage API, so it's on a per origin basis. You can't read and write to somebody else's web app, and you certainly can't come out of the browser and write to somebody's My Pictures folder or the system's My Documents folder. It's all on a per origin for your web app. But this is super powerful, and the real benefit of this is to get around issues that something like app cache has. So if you've used app cache, it's kind of clunky, it's hard to use. With the file system API, we can easily and dynamically cache individual files and folders very quickly, store them in folders, arrange them in a hierarchy, nuke that if we need to. So as a quick example of caching an image file, for instance, just a PNG file, we're going to use our friend XML HTTP request to pull that guy down. And we're not pulling it as a string, we're going to pull it as an array buffer. So we'll set the response type, and we're just going to get a raw byte array back from that image. When we get the response, we'll open the file system using WebKit request file system, give it a store, so maybe we're going to store a megabyte worth of data in this. We'll use the file system's root directory, just the root entry of my file system, and we'll call it image.png. We'll create it if it doesn't exist using this param here. When we get back a file entry, we'll then write that response of the XHR out to the file system and save that data. So this is just creating a file writer object. We can set up events for when the write is ended, if there's any errors that happen. And the important part is this guy right here, this writer.write. We're going to write out that data, the response of the XHR, create a new blob from the response, and that's going to be saved. The image is going to be saved locally to our web app, and we can use that as if it were a local resource to our web app. So that's the final product. But you can see there's a lot of callbacks that are involved here. So I have at least 1, 2, 3, 4 to 5 levels of sort of callback spaghetti that's happening here. So callbacks are hard. People don't like to deal with them. This is a famous quote that I just said. But I wanted to make this simpler for developers. I'm really passionate about this API. It's very powerful. So I wrote this library called Filer.js, and you can check out the GitHub URL there. But essentially what it is a library that wraps common Unix commands on top of the file system API calls. So we have things like ls and cd and copy, and the things that you know from a command line interface. Makes it super easy to use this API. If I want to copy a file, for instance, filer.copy, the file path you want to copy to, and then renaming it as well. So super handy. It makes the whole thing much more approachable if you're familiar with this sort of development. So let's see a demo of this guy. So this is called the File System API Playground. And essentially what this is a web app that sits on top of the File System API. So right now I don't have anything in this guy, but I can easily use HTML5 drag and drop to add some files. Boom, I can add some text files. I can open these files, right? So there's this sort of notion of using this resource locally with referencing it via URL. I can use that within my web app. I can also read this file and preview it if I wanted to using the file reader API and get some metadata such as the date and last modified times. I can use Filer.js in the API to rename the file. But the best part about this is I've actually cached these resources. So if I refresh this page, my web app right, has those values and those resources saved in them. So all the changes I made are being persisted, which is really awesome. You can create files and folders. So you can create a folder using the API. You can drill into it, import some data here. Luckily, it's after lunch, so you guys don't have to get too hungry. But this is really great. I mean, this is native stuff, but it's on the web. We can write and read files and folders now using the Filesystem API. So you're probably asking yourself this. This is great, but if it's only in Chrome, like, why am I going to use it? Then I'm like, oh, yeah? So again, I really like this API, you guys. So I decided to implement a polyfill shim library that sits on top of IndexedDB that then you can use in your web app to have basically the Filesystem API in browsers that support IndexedDB. So same web app, right? Same web app I just showed you running in Chrome is running in Firefox. And I can add files and folders to this guy. Maybe it's a nightly build, so I don't know. There we go. And if I refresh this app, those files that I just wrote to the web app are preserved. So that library is called idbfilesystem.js, and if you're interested in this API, the Filesystem API, check it out. It basically means that we can now use this API relatively performant way in the browsers that do support IndexedDB. So I'm super stoked about it. I hope you guys get stoked about it too. Files and folders, the web can do that. All right, number 5. This one looks suspicious. Totally is busted. Just making sure you guys are paying attention. The real number 5 is serverless downloads. So we got data in the Filesystem API. We're storing data in our web app. Where's my clicker? But what happens when you want to get data back out of your web app, right? So for a long time, if you wanted to download a file and trick the browser into downloading a file from the response of your server, you'd have had to do something like this. You would send a content disposition header as an attachment. You give it a file name. And essentially what this did was when the browser hit this response, the browser would it would trick it into downloading a file, and it would invoke the browser's download manager. But what we have now is a lot of people are writing thick clients, right? Maybe there's no server involved whatsoever. So how do you do this? How do you send a header if you don't have a server? It's kind of impossible. So the smart folks in the web community were like, hey, we can solve this. We got this great idea. Let's make an attribute. We'll call it download. That makes a lot of sense. And what download does is you can use it with an anchor tag, for instance. And so what happens is, normally what happens is if the user clicks on this href to this logo.png, what happens is the browser will open that image in a new tab, and you can view the image. That's cool. But what happens if you have download specified, this attribute, and you can give it the name of the file you want to download as, is that it's going to trick the browser into doing the exact same thing as the content disposition header, and then you can download that file instead of navigating to that resource. So if none of that makes any sense to you, I have an epic novel creator here. And this is just a text area that I'm typing into. So let me bring this up a little bit. So just to show you that I am typing live. So I'm just typing in this. I'm composing my epic novel, and then I want to have the user save what they've just done. So I can do that using the download attribute. When I click this button, I'm going to create a txt file, a text file, in JavaScript using the Blob Builder API. Create a dynamic link in JavaScript. Attach that download attribute as myfile.txt as its value. When I click that, the browser's not going to open that resource. It's actually going to download the file that I just created in JavaScript. And if I open this, it's going to be native to my system. And as you can see, the text content that I just pulled out from that text area has been saved. I've just downloaded a file in JavaScript, all client-side, no servers. That's pretty sweet. So we have the ability to save data in the file system. We have the ability to get it back out using the down attribute. What about getting data in between apps? Now, there's this thing called web intents, and I encourage you to go to Paul Kaelin's and James' session later in the week. But one way to efficiently transfer data is rocket ships, of course. But another way is with post message. And in order to describe this and set this up for you guys, I want to take you down sort of memory lane of post message. Post message started off as a way to communicate with a web worker or a window object, right? You could send a string. You could send hello world to a worker, and then it could, I don't know, do something interesting with that. But what happened was like, hey, people are gonna, the browsers like, or developers got smart and they're like, let's just send JSON stringified data. So they stringify some JSON and pass like commands in and out of a worker or to a window object. So that was totally cool. But then the browsers were like, hey, like we can do better. Let's just do that for them. Let's just not have the ability to stringify JSON, but let's just do it under the hood. So what happens is the browser would JSON stringify and JSON parse this message out. So that was cool. That got us one step further in sort of this post-message evolution. But then the third step that came along was the ability to send more complex data, right? You just saw me send a file, create a file in JavaScript. Why can't I send a file into a web worker and do something interesting with it, or a WebGL texture as an array buffer, right? We have binary data on the web now. We should be able to do interesting things with it. So eventually the browser's like, hey, we'll open this up. We're going to use a structured cloning algorithm to be able to pass a blob, a file, into the web worker and process it. Or you could send an array buffer. So this is really, really cool, right? And a lot of the modern browsers support this. Is you can send a massive data set into a web worker, do some computation on it in this sort of multi-threaded environment, and then get it back out and do something interesting. So the real problem with this, though, is that these are all the methods I just covered are copies. So that becomes very inefficient when you're copying and sending large amounts of data in and out of a web worker. It's kind of pointless to have this awesome multi-threaded web worker doing its thing, but if you can't get data in and out very quickly, then it defeats the purpose. So of course, I wouldn't be up here if we can't do better, and we can do better. And that comes via transferable objects. Transferable objects are something that the WebGL community thought up because they need this ability to do processing on large amounts of data. And so you can see this guy is using our old friend, but it has different semantics, and that's why this method is prefixed with WebKit post message. This is something that's supported in Chrome. So what happens with the new post message is that it's a zero copy. So if you're familiar with like C++ or C, think of it as a pass by reference rather than a pass by value. And so the ownership of this data is actually transferred from your main app to the worker or window context that you're posting to. And so what happens is that this becomes actually really, really efficient. And up to 50 times faster. I measured this in Chrome 17. So Chrome 17, that's sort of long gone now, but it could even be faster. I don't know. But the important point of this graph are these last two columns here. In Chrome 17, the difference between the regular post message, which is on the left, the middle one, and the right is orders and orders of magnitude. This is a logarithmic scale, keep in mind, faster. So basically what I did in this test was I sent a 32 megabyte file into a web worker. I didn't do any processing on that file, and then I sent it right back just to see how fast that was. And I measured that, and you can see the rate, the round trip simulated rate of that is super, super fast. So this is really sweet for things like physics simulations and, again, WebGL, gaming. I have an example of this, and unfortunately this is not super sexy to demo, but this is my awesome sexy demo for transferable objects. This page has basically set up a web worker. I got a worker ready to be post message to. Now when I hit this run button, it's going to use that new WebKit post message to send data into a web worker. I think we're sending a 32 megabyte array buffer. So this 32 megabyte file into a web worker, and then sending that right back, seeing how fast that is. So I'll hit this, ready? Boom, 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 boom. 6 milliseconds, 5,000 megabytes a second simulated rate. I mean, that's kind of ridiculous, right? That's awesome, that's awesome data, and that's a lot of data. 32 megabytes is no joke. Pop out a full screen here. Just to show you the difference, I'm not picking on any browser in particular, but a browser that doesn't support transferable object, you can actually noticeably see the difference here. Let me zoom in. So when I hit this, run, boom, boom. So not only do the numbers speak for themselves, 157 as opposed to 5,000 megabytes a second, but you can actually see the delay, right? Visually, the delay that it takes for this web app to make that round trip request. So significant difference using transferable objects and performance. In my opinion, this is something that the web platform and workers and window and post message should have had available in the first place. But this is sort of a common thing in the web, right? We're sort of incrementally improving on what we already have, making it better and better and better every time. This one's only in Chrome. Again, something that should be in every browser. Efficiency is something we love in the web. How many people think the web can access native hardware? Not using PhoneGap or something like that. Okay, got some believers, I love it. You guys know this is when it's going to be confirmed. It's confirmed, it's totally confirmed. What I mean by accessing hardware is device APIs. There's a whole working group dedicated to figuring this stuff out now. And what I mean by devices are things like geolocation and accessing the accelerometer of this laptop, using WebGL to access the GPU, right, the graphics processor unit of the laptop, using a very high-level JavaScript API. I just showed you the Filesystem API. We can read and write folders and files on the web now. Whether I'm online or offline, network connectivity, all via JavaScript, battery API, gamepad API, all super possible. WebRTC and web audio, I want to briefly mention on. There's 2 dedicated sessions to these 2 topics because they're noteworthy and very complex, and they should have a dedicated session. But being able to access voice and video on the web is sort of this coveted grail, right? I mean, we've wanted to access the microphone for a long time or get camera for a long time, but you've needed a plugin to do this. So this is one example of being able to sort of the first step along this path to do that. With one attribute, this xWebKit speech attribute, we can annotate an input, and the browser is going to annotate it with this little microphone input. Instead of typing in this web app, it can actually interact with the microphone in this web app. I want some coffee. All right, it worked. Sometimes it doesn't. Or you get some weird issues. But this is really great. A different way to interact with my web app. I don't have much of an API to play with, right? It's sort of happening under the hood. But I'm accessing the microphone of this laptop using one attribute. So what we have now is something way better. We have camera and microphone access via Get User Media. Get User Media is coming out of the WebRTC project. Navigator. Either Get User Media or the prefix version. Also, Christian from Firefox tells me this is coming to Firefox in nightly builds, so that should be on there as well. But now we have proper access to the camera of the device and the microphone device. With this call, I can specify that I want audio access, I want video access, and what I got to get back is a stream object representing that data that I get from those devices. And then what's really cool is, again, I'm using different parts of the platform that have already existed for a long time. So I'm using a video element. HTML5 video is one of the sort of core features of HTML5 when it first came out. And instead of setting the video source to a movie file or an OGV file, I'm setting it to a blob URL created from the data I get from the camera. So instead of a file, I'm just sending the camera data and the microframe data directly into this video tag. So that's what's going to give us the ability to render live to a video tag. So I have a little demo. There's a lot of really cool demos people have created using Get User Media and the ability to access the camera. This is my demo. I do trust this app. I made it. I wrote it. So I'm going to, if you can't see at the top, I'm going to allow access. So we'll create a video element in JavaScript. And there we go, live from stage. You can see behind me. So this is great. No plugins, right? This is just JavaScript on the web. But again, I can combine this with different parts of the web platform. So I can use CSS filters in real time to overlay this video with effects like grayscale. How about a blur effect in real time? That's pretty trippy. Inversion effects, right? Just using CSS, applying to this video, I can do all that, and it's still really awesome. Looks great. I can combine it with Canvas, right? And do a little photo booth effect. All right, that's enough of that. One of my favorites, though, is this one called Webcam Toy. So I'll grant access to this. It's OK that uses my camera. This is not going to use CSS filters, but it's going to use the power, I'll stay in camera, the power of WebGL, right? So with WebGL, we can access the GPU, that native access. And we can do things, really awesome things with shaders. Shader technology is amazing. So again, this is all JavaScript using WebGL, no plugins. Look how fast it is. It's really trippy things. Let me get to the cool stuff. There it is. Yeah, this one's cool. Super trippy. Oh yeah, 3D. This is after you've had a few drinks at the party tonight. So just amazing things. People have done things with augmented reality, right? Holding up a paper, a piece of paper with a QR code on it, and the camera tracks you. So play around with those when I put up the slide decks later. Just some really awesome, amazing things. Support for this is actually really good. Opera just released Opera 12 that has this. They've had it in their mobile version for a long time. It's coming to Firefox nightly, I'm told, and Chrome just released a stable version with Get User Media. So we can do camera access, we can do microphone access without a plugin now. HTML5 audio has had a little bit of been problematic, to say the least. But what we can do now with the Web Audio API is make it sexy again. So HTML5 audio is great. It's just like video, right? Without a plugin, we can play audio on the web, just populate a source attribute of an audio tag. Play it, that's cool, we don't need a plugin. But what if you want to do something like this? What if you want to visualize that data in real time, get the frequency analysis as it plays, visualize that on 2 canvas tags, apply some WebGL transforms, a little bit of a reflection on the bottom there, and do that with HTML5 audio. But what we have now is the ability to tie into what's called the Web Audio API, tie in an audio tag as a source to that API. So instead of driving the Web Audio API via an XHR request or something, we can just send data directly to it, via this audio tag. So that's really, really important. This doesn't have to just be a video. It could be an audio tag. It could be a video tag. So imagine I had an HTML5 video playing, and that is the source to the Web Audio API. Then you're visualizing sort of effects as movie changes and dark monsters pop out. You can really scare people. But the way this works is really easy, right? So we have the Web Audio API. I encourage you to go to Chris Wilson's session later in the week about this really amazing API, a lot of low-level access to the core audio of the system. High-level JavaScript API on top of it. I'll create an audio context, and thus I'll create, oops, those are the notifications. I'll create a HTML5 audio element. I'll populate it with dopebeats.mp3 as its source. Set up a couple controls, some autoplay on it. And the important integration point between these two, sort of the old audio working with the new web audio and the capabilities of that API, is this create element source, media element source. And that's how the audio tag is sort of filtered and piped into the Web Audio API. Which leads us conveniently into number 10. So I get this one a lot. A lot of people ask, hey, how come HTML5 can't do streaming audio or streaming media? And it actually can. It can do that through another old friend, WebSockets. So WebSockets have been around for a while, and it's sort of suffered from the same limitation as web workers, right? You can only send just basic data. You can send string data. And that's not so handy, right? We have things like files and array buffers and the ability to use complex data. We should be able to send and stream multimedia or files to web apps. So we can do that now with WebSockets. And WebSockets has a new sort of socket.binary type as the property you set on this. And you set it to a blob or you set it to an array buffer. And that tells the WebSocket that's going to be speaking binary data instead of just regular string data. And what's awesome about this is on my onMessage event, I can use that directly to set an image source, for instance, from a blob URL. Instead of having to base64 encode data on either end and decode it, which is, there's an overhead associated with that, we can just use the data directly that we get back. So I have a couple of demos of this. The first is a Chrome extension. So I have a little Chrome extension installed here in the top right corner. I'm going to click this guy. And imagine this is my viewer, right? I'm going to basically do a sort of screencast from the web. This is my viewer. Imagine this is somewhere around the globe. I'm going to open a new window. Pretend that's here. So when I click this guy again, it's going to fire up a WebSocket, a binary WebSocket, and use the Chrome extension screen capture API to capture the current tab. Let me go to google.com. Go to sports, because sports is great. So on the right side, I have my presenter. This is just capturing the current tab as a PNG as I scroll. It's sending that data through a WebSocket to the remote party. And you can see it's very performant. I don't have to do any base64 encoding. As I'm scrolling on the right on the live page, that image is just being sent across the wire in near real time using the WebSocket. That's really, really sweet, right? We can do this now thanks to the Chrome extension API, yes, but also via a binary WebSocket. inception. But we can also do other things with different types of media. So I just showed you a little teaser preview of the Web Audio API, the API that allows you to analyze sound in real time as it plays. What I have here is a page that sets up a binary WebSocket, and it's going to use the file reader API to essentially cut an MP3 file up into multiple smaller chunks. And then it's going to connect to that WebSocket, send each of those chunks across the wire. On my left side here, the viewer side, I'm going to use the Web Audio API to schedule those chunks at very precise times, exactly when they should happen. So essentially, I reconstruct the audio on the other end and just sort of use the sequence that it should be in, and then visualize that using the Web Audio API. So I'm going to load up an MP3 file here on my DJ machine, this guy in the right corner. Binary WebSocket, Web Audio API. No sound. There we go. There's sound. So again, streaming from one client, streaming audio data using a WebSocket, using the Web Audio API to reconstruct it, and then visualizing it in real time. You can see I have the chunks coming in, so I'm receiving sort of mini chunks of that MP3 file as I reconstruct the audio, and sort of the current time as it's playing. Just to prove to you this is streaming, if I refresh this, we're going to come back to the exact same spot. So that's using two brand new sort of capabilities of the web platform together to do something that you probably, maybe not, hopefully didn't think was possible, streaming audio on the web. No more plugins for this. We can do it now using the web platform. So that was really quick. I covered a lot. And I just want to point out that we did cover sort of everything under the sun. The web can do really amazing things. I hope you do agree. CSS, whether it's the new CSS stuff for web application layout and design, doing data binding, doing things like file access, accessing the native hardware, efficiently transferring data once you have it in your web app, and then doing really awesome things with some of the older capabilities of HTML5 multimedia and also some of the newer stuff. Combine those two with the integration points. Just want to point out we have a Google Plus developers page. If you guys want to know more about what Chrome is doing with HTML5 and the open web, check that out. If you're not using Chrome Canary or the developer channel, Chrome really does heart HTML5. A lot of this stuff I just showed you, again, is very new. So play with it in Chrome. File bugs on newcrbug.com. Let us know what you think. Give us feedback. This presentation will be up on my GitHub account at HTML5Ken as soon as I exit this stage. You can also access these slides at HTML5 with the 5 spelled out, can.com. And there's my social stuff if you want to follow me or tweet at me. I'm happy to take questions here, and I'll also be available after the show and as well as office hours tomorrow. So thanks, guys. Appreciate your time.